everyone and welcome again to my channel Tech Traversal. So today I will discuss about level order traversal in binary tree. This is a very important topic, and if we know this technique we can solve a lot of questions in Leetcode. Along with that we can solve so many questions in interview also. So this level order traversal is also known as BFS technique of traversal, means breadth first search. So first thing is we will learn how to do a level order traversal, and then we will solve this question 102, which is binary tree level order traversal in Leetcode. Then it will clear all our concepts, and along with that we will learn how to code. So let's jump into it. So level order traversal in binary tree means we have to traverse this tree level by level. So what level means here is, so this is the first level where root exists, then this is the second level, and this is the third level. So how we have to traverse is, first we have to print this one, then 9, then 20, then 15, then 7. So in this case we can see that for 9 there are no children, so that's why we are directly after 20 we are going to 15 and then 7. So if we do a level order traversal for this, then the outcome will be like this: 3, 9, 20, 15 and 7. Now the question can come in a different way. So the result they want is every level what are the elements are present, so print it in a 2D format. So you will be expected to generate the output like this. So in the first level only 3 is there, and second level 9 and 20, then another level 15 and 7. Suppose we have another element here called 6, so that time 6 will be here before this. Now the question is how we can traverse a tree in a level order fashion, and what additional data structure or anything what we have to use here. So that we will see next. So how we can traverse a tree in a level order fashion. So in level order fashion what we can see is whatever going first, then that is coming out first, and after that we are traversing the other things. So here in this case we have to use a queue data structure. So how to use queue here we will see now. So suppose this is one queue, so our first job is to put this root node into the queue. So we will put this root node into the queue, and after that we will pop or dequeue this element, and we will insert the left first and then the right of this element. So we will just simply put 3 here as a result, then after that we will insert 9 here, then we will insert 20. In case there are no left or right for any element, that time we will just simply omit that. So in the next step we will just pop out 9, and then we will insert the left and right, but in this case there are no left and right for this element, so we will just move next after printing it here. Now next we will pop out 20, and we will add 15 and 7 here, 15 and 7. So first the left child, then the right child, and we will print 20 here, and then we will proceed further. So we will pop out 15 and print it. For 15 there is no left and right, so we will just simply omit that, and for 7 we will just pop out and print here, and for 7 also there are no left and right. So we will stop when the queue will become empty. So this is the way we can do a level order traversal. And here one thing we can see that if there are no children present for a element, that case also is handled well, right? Now this is the technique to do a level order traversal, but if the result we have to generate in a 2D fashion, like each level what are the elements are present, so that if we have to put it in an array, that time the solution will be a bit different, which we will see next. So to generate the answer in a 2D manner we have to do pretty much the same thing, but this time we need a variable called size. So we will keep a variable called size. What is the use of that? I will come now. So our job is pretty much same. First we will put 3, and now we will check what is the size of this queue. So that is 1 now. Okay. Now next time we will traverse that many time, which is the size, and we will keep it in a normal array. Okay. So we will pop it out, and then we will insert 9 and then 20. So in the next level again we will check what is the size. So now the size is 2. So in the first level the size was 1, and the next level the size is 2. That means we have to pop up 2 element, then we can go to the next level. So now we will again create a blank array, and we will pop this element 9 and we will keep it here, and for 9 there is no left and right, so we will not keep anything. Then we will pop 20 and we will keep it here, and left and right is 15 and 7, that we will push in the queue. And as the size was 2, that means we are only allowed to pop 2 element in this particular iteration. Now this is also done. In the third time we are again checking what is the size of the queue now, and that is 2. So in this case also it is 2. Now we will iterate for twice, and we will again create a empty array, and now we will pop out 15 and keep it here, and then for 15 there is no left and right, so we will pop out 7 and keep it here. For 7 also there is no left and right, and after that in the fourth iteration we will check what is the size of the queue. So this time it is 0, means it become empty, so we will stop the process, and we will return this one as result. Now we will check how to code this one, and we will solve the problem which is present in the Leetcode. So what will be the time complexity and space complexity in this case? So time complexity will be O(n), because every node we are traversing only once, and here n means the number of nodes in the binary tree. And auxiliary space will be O(n), because in worst case situation every element can be in the queue, so that time it will take the O(n) space. So the time complexity will be O(n), and the space complexity will be also O(n) in this case. So now you will do the coding here in Leetcode. In Leetcode, the question what they ask, so there they want the answer in the second format, means in the 2D format where level by level we have to show them, right? So we will use the queue technique, and then we will determine the size and we will go forward, right? So here the result they want is in list of integer format. So how we will do this is, first we will define a variable called result, which will be a list of list, right? Then what we will do is we will first check that if this root is null or not. So root, if it is equal to null, then in that case we will just simply return the result, means a blank array list. Then next we will define like the queue, and then we will add the root into it. So for that purpose what we will do is we will define the queue. So queue in Java you can use the linked list, okay, and there the node will be a tree node which is defined above, and then we will add the root here, so that will be the initial thing in the queue. Then we have to loop over this queue and do all the other operations until the queue is empty. Okay, so we will have to write if the queue is not empty, for that moment we have to keep on going, and here we have to define the size first, like what is the queue size now, that many time we have to iterate. So it will be like queue dot size, first we are determining, and in every level we will do iteration for that many times, and in every level we have to store the result of each level, right, in an array. So that is actually in this case it will be a list of integer. So our job will be to define a list of integer before starting the inner loop, right? And here we have to collect the result for that particular iteration. So what we will do is for integer I equal to 0, then I less than equal to this size, means that many time we have to iterate and do a I plus plus. Now we have to pull the result from the queue, or we have to dequeue the element, right? So what we will do is tree node, we will get a tree node out of it when we will pull that result. So que dot poll, if we do, we will get the element. So in the first case we will get the root element. Now after getting that element, we will simply add it to the result. So li dot add, then node dot value we have to add there, and our job is to next like put the left and right child of that node which just now we got, right, only if they are not null, right? So we will simply write if node dot left not equal to null, then put it in the queue, or if node dot right not equal to null, then put it in the queue. And at the end of this particular loop, we have to add that result in the main, like say result list, right? So this is the first level, whatever values are there we got, and we are adding it to the main result which we have defined here. And at the end it is simple, we have to return this result, then we are done. Okay, so just submit this solution and it is working. So this is the way we have to do a level order traversal. Now we will solve the other problems which are related to level order traversal. So as we learn the level order traversal, those other problems we can think easily and we can solve also easily. Thanks for watching.